Let me start my talk with a funny example. Imagine you get a new job and you walk into the office for the first time, and there it is, these massive screens with dashboards on the walls, with dozens of gauges, numbers, and bars. It looks so cool, it is so futuristic. It is like a cockpit of an aircraft. And you're excited to work there. And only a few months later, the reality slaps you in the face. These are useless. Like, you understand, nobody in that office knows what these gouges mean. Nobody checks them daily. If anything changes, nobody will ever see that. And nobody even knows how it works because some guy who created it left a year ago or so, and we left it on that wall just because it looks cool. And there is nothing bad that it looks cool and you want to keep it. But here's the difference with the aircraft. The aircraft actually needs all of these bars and gouges to fly, but the software company doesn't. And I mean, if you see yourself as a pilot, that's fine. You can even wear a pilot uniform when you code. That's up to you. But we as software developers need to face the reality that in terms of like all of this bars and gouges, we should only put the things that we actually need if we want to make any use of it. And this is what this talk is about. What do we actually need and how do we facilitate it to not look like that office that just puts nice things on the wall to look cool, but to look more like a pilot who is actually using it. So I already presented myself, so I guess I can speak this slide. Only thing I want to add is that because I'm running an agency in Munich, the mistakes of my clients is sort of my business. So what I'm telling you about is the typical real world examples. Even if they look small and rather simple, this is actually the thing that gives us jobs here. So what I'm presenting is sort of examples from the real world. Now let's first think what even is telemetry. And for me, my introduction in the world of telemetry starts somewhere with the RC toys. Imagine driving a RC car or flying a drone. What would be the difference? The main difference is that you can control the RC car just with your eyes. It's easy, whereas with a drone, it's not so much. To fly a drone, you need to see what the drone sees and to feel what the drone feels. And it's called telemetry. It's a feedback. So drone needs to gather all the data from all of the sensors, its positions, its battery. It needs to report back what's exactly happening at this moment. And the operator has to check it on some sort of screen. And the operator would normally put only the things that are actually needed on that screen to be able to not lose important signals and to control the state of the system. So for me, this is the best example of telemetry, to be honest, because when flying a drone, you really only need a few things, and not having them will make you crash. Simple as that. And in the software world, we often overlook this part, but in fact, not having the right telemetry will make you crash at some point as well in software. Imagine flying with a operator screen like that. I doubt you will fly far with this. So I'm not a critic of tools like Datadog or tools like New Relic. I am a critic of using it in the wrong way, because when you just create an account, it will generate you the standard dashboard. It will be trash. Like 90% of the cases, it will look cool, but it will be useless. So what we're going to do in this talk is we will start really from the basics and think, what is this minimal but very usable set of the tools that we want to have as software developers to run our servers systems reliably? And what is the easiest way, well, with OpenTelemetry, obviously in my talk, to have this data delivered to us. So what is telemetry in software now? For me, a good memories of, if we think of telemetry as a feedback, for me, the first memory, like to understand when the laptop is doing something, is coming into some critical state, was simple. Was the old cheap Acer laptop. The fans started spinning as hell, and I could hear it. So this was like a primitive telemetry of the old days, so to say. If my script makes my laptop spin these fans, it means it's thinking something is happening. This is the most primitive way that I got this feedback, and I think like a majority of us back then. Then, of course, there is logging. Another primitive but useful thing. So we want to see when things fail, and this is a typical traceback that we would see in our console. It is some sort of telemetry channel as well. The program reports back to us that something is wrong, and we see what's wrong exactly with the console message. Then I bet half of you did this, info ASD, 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 whereas some of you might type cure. That's about your tastes, I'm not sure. But this is another way that we wanted to send the signal that some particular line of our code has been executed. The more perfectionists would use something like here if they want to be more expressive in their logs. Finally, when we go into more advanced telemetry level, some of us, majority of us, has at some point of time put this, like time before something happened, then starting something, and time after something happened, so that we see how long something took. And that was a primitive thinking, but in the right direction, because back then telemetry was not a thing yet, but the thought that we have that we want to control how long things take in the code and which lines are executed and where it crashes is correct. It's just a very, very basic way of presenting it, but it is a very beginning of this telemetry story we are talking about. Now, thanks for traveling with me with these old good times. To rush things a bit, I would just say that we cannot understand a complex system if it's a black box. Back then, in those scripts, we could still debug things manually, but now in the era of microservices and distributed system, serverless functions and so on, it's not possible anymore. It simply doesn't work. So the only way to light up those black boxes of this dozens of functions is with high-quality telemetry, and that are distributed traces, metrics, logs, and more. We need telemetry as a built-in feature of our services, right from the scratch. Remember the moment when you switched from print to something like logging.info, and that made you upgrade from normal developer to senior developer? Well, now this is the next step. When you upgrade from logging to something like OpenTelemetry, that makes you a superior developer. Now let's get started with OpenTelemetry. So it has a good story. Why the story is important, I will not focus on this long, but I hate when people on conferences present a new big thing and this new big thing goes away in a couple of years or generates a major version that's backward incompatible. All of us hate it. So before I even start talking about OpenTelemetry internals, I need to assure you that it stays. It stays for a while because it didn't appear like from the nowhere. It's a merging product of Open Tracing and Open Census, which are backed by the huge companies like Google, Uber, I think now also Facebook. It has a story, and this story is not a couple of years. And also people developing it have been developing it for years. And when they merged, they really picked the best of two major systems and merged together. And now here we have it, OpenTelemetry. So it's going to stay, most likely. What are the benefits of it? Obviously, with unified approach, we are collecting different types of telemetry through a single framework that simplifies observability of the infrastructure. Then with interoperability, I mean that's the support of wide range of backends and tools, allowing to adopt OpenTelemetry without abandoning code for existing observability tools. Python included, obviously. The Python support is perfect, and all of the major Python framework as well. Finally, rich context is combining traces, metrics, logs, and this provides a comprehensive view of the system performance and health, enabling to find problems faster. Let's go over OpenTelemetry primitives, the signals, which are traces, metrics, and logs. So traces used to track the path of a request through various services. That's why the traces are tracing the request. Metrics are the quantitative data points that measure the characteristics of systems and applications over time. This is where we report numbers. And finally, logs, I do not need that. We need explanation about that. Now, how it actually works. Instrumentation. This is an application and infrastructure components that are instrumented with the SDK of OpenTelemetry or other compatible libraries, and they generate the data, the telemetry data. Then this data is sent in the collection step to the OpenTelemetry. Then we have a collector, which is collecting this data sent. After data is collecting, because we sent more things than we need, there is a processing phase, and the processing is sort of like filtering, maybe some enhancements and transformations or optimizations over the data. Finally, after that, exporting, so that the end system can visualize it nicely or provide us some analytics. And this is just for recording, I guess. If you will want to see in details, you can go back to this chart. These are the things that I just told you, but in more visual form. So I think in the remaining 5 minutes or so, I can show you Python examples. Well, obviously, it's a Python conference, which I would love to because the integration with Python is amazing in my opinion. So from simple to more advanced, like to add tracing quickly to your application without any changes of the application code, you can use this approach. This is really a rapid integration. You just use a command of OpenTelemetry instrument before you type Python. So it's like a wrapper that will provide you with general analysis of your Python application without any customizations from your side. It's called auto instrumentation. One problem here, well, one consideration here is that this might introduce a slight performance overhead because when you run this, it dynamically injects instrumentation in your program at runtime. I wouldn't say you will feel it, but you have to consider it. Now, one level lower is the framework instrumentation, and it is also sort of automatic, but this already requires you changing the code. In this example on the screen, I use Flask instrumenter, and this is as simple as that. You need to initiate the processor for your spans. You need to add that processor to your tracing, and then you run the simple line Flask instrumenter.instrument app and give it over your Flask application instance. It will take care of the most of the things you want in typical like web backend for you. It will record the request response cycles. It will count the errors. It will report different HTTP codes properly. So this is a minimal change, minimal intrusion into your application. However, this already gives you good insights about what's running. And of course, it's available for all Python major frameworks. When I'm speaking about good support of Python frameworks, I also want to mention that it's not just about Python, because although Python is our preferred and beloved language, I suppose, we also have things like databases, caching systems, and so on. And ideally, this all integrations that we are using with external tools in our application should be supporting the same telemetry format. So this is a very good thing because in the era of distributed systems, you want to see database traces equally good as your application traces. And thanks to the support of a wide variety of services and applications and backends and frameworks, highly likely all of the things you're using do speak OpenTelemetry protocol. Next, custom instrumentation. Yeah, this is a bit more manual. However, with operator in Python, this is also not so difficult, I would say. I think that I try to make the code really self-explanatory. So we add this with block into our code, and then we start a new span, and we give it a name like complex algorithms. This way, the OpenTelemetry backend knows that it has to measure everything that is in this block separately. And then we do some calculations, and then we see the stats and the behavior and the life cycle of this block separately to the standard metrics that we collect otherwise. Next one, I want to say a few words about custom data processing, and in this case, it's batching. So OpenTelemetry processing capabilities to filter, batch, and enhance telemetry data before exporting allows this. And in this example, batch span processor collects traces and sends them in batches, simple, which is configurable for time and span count. And this is just to minimize your network calls and enhance the performance of the application to have more control over the process of reporting your telemetry. And the next point here is filtering. Filtering involves selectively choosing which data points should be processed or exported based on the specific criteria, and this can help focus resources on the most meaningful telemetry data and reduce storage and processing costs for the data that is not so important. And here, filtered span processor class, it checks each span at the end of its life cycle to determine if it meets the filtering criteria, like, for instance, if it has some specific attributes. And then only spans that pass the filter are exported and given forward to the system that we want to use to store and present telemetry data. So this way we can focus on the most relevant and critical information. Now I rushed over these techniques of simple reporting with Python. Now I want also to show you how can we see the results. The default tool to see data in OpenTelemetry is called Jäger. And Jäger, it's not like Jagger. It's Jäger, like a hunter in German. Also, the logo suggests that it's probably a Bavarian hunter by the hat. It's really basic interface. It's good enough to understand what's happening, at least in this example, it's just from their documentation. It's for the HTTP server performance and timing looks like Chrome developer tools or any other service for the matter looks similar. However, again, this is just a tool to present telemetry results, and you have so many of them. You can use your Kibana, anything that you really want, any tool that you are used to be seeing in your life cycle of software development. You can highly likely connect it to present the data collected with OpenTelemetry. OpenTelemetry is a standard and a protocol, not so much to present the data, but to collect it. That's the point. And another tool that is there for a while is Zipkin. This is how it looks like. To me, they all look the same, so it's really more of a custom, which one you like the best. I think we can even have a few questions. So I'm done with this talk, and yeah, I think we are on time. So let's hear some questions. Thank you.